Fuel efficiency, sufficient horsepower, and lower emissions are all targets that commercial fleets are trying to achieve when they operate trucks with diesel engines. When they're looking at these different characteristics of how the engine works, really what they're trying to do is lower total cost of operation. So what role do fan drives, formerly called fan clutches with the older days, play in achieving these goals? My guest today is Dale Johnson, a field service manager at Horton. Dale has worked at Horton for over 33 years. He started as a machinist, worked in product assembly, worked as a warranty technician, and is now a field service manager. He's got the product knowledge to help us to answer our questions, and he has the expertise. So I'm really looking forward to talking to him. Dale, welcome to the Heavy Duty Parts Report. So happy to have you here.
Thank you, Jamie. I'm happy to be here as well, and thanks for having me on.
So, Dale, most people in heavy duty parts, they know that Horton manufactures fan clutches, fan drive technology, but we also have a lot of listeners who may not know the full scope of Horton. Maybe you could start off by just giving us a brief overview of who the company is and what they do.
Horton is a privately held, family-owned company with manufacturing facilities, two here in the U.S., one in Schweinfurt, Germany, and sales offices all across the world. So we're a global company, and we not only manufacture fans, clutches, we also manufacture fans and some suspension products.
No, I didn't know about the suspension products. So there you learn something every day.
Horton roller bushing, yes.
Ah, okay, that makes sense. So I'd like to talk about a specific product today, the Horton RCX fan drive. What type of fan drive is this, and what applications does that product fit?
The Horton RCX fan drive is a variable speed electronic sensing viscous fan drive. It's a lot of information in one phrase, but it's unlike the fan drives of the past, the pneumatic fan drives, and even some of the first viscous fan drives that it turns on and it turns off, the older style ones. The RCX is a smart fan drive. It knows when and only turns on as much as it's needed to cool the engine or the other components on the engine.
What's the difference between, like, when we say viscous or we talk about those older style pneumatic fan clutches? Like, what is the difference there?
The pneumatic fan drives were controlled by air pressure. Basically, most of them they're spring engaged, air disengaged. So you apply air to it to disengage. When it needs cooling, they take the air away and then it goes up to full speed. Whereas with the RCX, it has a viscous fluid internally. It works somewhat like a torque converter, to kind of do an analogy. The more fluid inside of the fan clutch in the working area, the faster it goes, and the lesser fluid inside, the slower it goes. And this is controlled by the ECM. Reading a signal comes from the ECM to tell the fan drive to turn on or turn off. And then there's also a fan speed feedback within the fan system, a Hall effect sensor. It knows how fast the fan drive is going, feeds that back into the ECM. The ECM will tell it whether or not it needs more or less fan speed.
Earlier in our conversation, you mentioned that there were older style viscous fan drives. What problems have some of the original viscous fan drives had in the past?
The earlier stages of the fan drive, the viscous ones, they had a very high residual or off speed, resulting in more parasitic loss. And there also controllability with the fan drive itself. You couldn't control the fan speed as well as you wanted to be as efficient as it can be. So we've developed a new valve and internal design to control the fan speed by being able to control the flow of the viscous fluid inside.
Right. It sounds to me like the technology just hadn't evolved yet to the point where it is today. And of course, that had implications for the total performance.
Yes, that's absolutely correct.
And so if it wasn't as efficient, so I assume then that had some implications with fuel consumption. And could you maybe go into a little more elaboration on what you mean when you're talking about that parasitic draw?
The parasitic draw is basically the the draw of the fan, as the fan's rotating, it takes horsepower away. And if your fan is turning faster, you have more parasitic loss. So you're using more power, more energy to turn that fan when it's really not required. So that's basically what it amounts to, that if you don't need the fan on, it shouldn't be running. We can control it down to about 100 to 150 residual speed in the off position.
Right. And that all has those implications, right? More fuel consumption, more emissions, less horsepower for what the truck needs the horsepower for. So all of that added up to something that was less efficient than what this new model is. So we're going to talk more about that in a moment. We're just going to take a quick break. When repairing a diesel engine, it is essential to only use high-quality engine parts. AFA Industries manufactures OEM quality complete in-frame kits, replacement engine parts, and seals and gaskets for diesel engines at great aftermarket prices. To learn more, go to afaindustries.com where you can request them to direct you to a local distributor. Check out afaindustries.com today. We're back from our break, and we've been talking with Dale Johnson from Horton about the technology and where it has gone with fan drive. So we were talking before the break about the older fan clutch styles and the original early models of the viscous style fan drive. Now we're going to talk about some of the unique features of this new model, the RCX fan drive that Horton has put out. Dale, tell me about the brackets. What's unique about them, and how does that impact the installation of the fan drive itself?
The RCX fan drive has an integrated mounting bracket. It's a one-piece design allowing for ease of installation. And it also has a heavy-duty cable protection bracket. In the event of a belt fraying or the belt comes flying off, it's not going to take out the wiring harness. It has a heavy-duty bracket to keep it from damaging the wire harness that controls the fan drive. It also has the Horton drac bearing in it for reliability and long life.
So can you explain how the RCX fan drive manages to impact fuel efficiency and horsepower while at the same time lowering emissions? So we kind of talked about the detractors from the older technology. I'd like to learn more about exactly how this works and how it almost seems too good to be true, right? Like better fuel efficiency, more horsepower, less emissions. How does a fan drive do all of that?
So basically, we'll start from here with a fan, a 30-inch or 32-inch fan. It takes about 75 to 100 horsepower to turn that fan from a dead stop. And with the old technology, with pneumatic fan drives, you start it and you stop it. It was starting from a dead stop. Well, with the variable speed fan drive, it knows how fast it needs to turn. So it's fully variable, anywhere from 100 to 2,800 RPM. It can go up to 100, then up to 500, back down to 200, up to 1,200, and then back down to 500, for example. It can go anywhere within that range between 100 and 2,800 RPM. And it only goes as fast as it needs to because the ECM is controlling it. And the ECM says we need more or less fan speed. It takes current or it puts current to the fan drive, speeding it up and slowing it down. Like, for example, 85 to 90% of the fan cycles are AC related. Well, this helps eliminate full-on engagements with the old style of fan drives. And it keeps it at the optimum operating temperature for fuel efficiency and power production. We'll just say it's 205 degrees is its optimum operating temperature, and it can keep it within 5 to 7 degrees of that.
Right. So with the old technology, whether it was on or it was off, and that didn't matter if the truck was running in South Florida or Northern Canada. So now with this, it's a lot smarter. It uses these ECM to sense what's going on in the environment. And because of that, it reacts accordingly. So as we were talking about before, we were defining that parasitic power draw on engine horsepower. So because of this variable speed now, what is the impact on horsepower draw?
It can reduce it up to 20 to 50% of horsepower drop. And because it has a lower speed, it doesn't have that residual drag that it normally would, that it would take to turn on. So it may never turn on full speed just because of the design of the fan drive. It keeps it at that optimum temperature. the parasitic loss is usually at the low end when you don't need the fan, but it comes on anyhow. Well, with the RCX, it only turns on as fast as it needs to keep the engine at the optimum temperature.
It has a positive impact on fuel consumption, maintaining optimum horsepower, and that lowers emissions. And then on the other side, with that optimum operating temperature, then it also contributes to protecting the engine from any kind of overheating or any kind of issue related to operating temperature.
Yes, correct. It keeps it at the optimum temperature. The overheating, is not an issue within the fan drive itself, as far as keeping the engine cool. And the AC, requirements, there can be up to 7 to 8 sensors on an engine on different types of vehicles that can call for fan engagement. Anything from a charge air to a hydraulic cooler to a transmission cooler, and obviously engine temp and AC pressure. All these different factors can lead into the fan drive engaging and disengaging.
So for our listeners on TNC radio who are operating commercial trucks, all those things you're doing right now, driving down the highway, you didn't realize how much was going on under the hood just with the fan drive alone. There's a lot to it. So when we talk about the development of this technology, when Horton is looking at some of the problems, I assume because of the not only manufacturing them new, but you also have some reman programs, you get to see a lot of what works, what doesn't. And then is that the way that Horton then develops these improvements in the technology to be able to bring out a product that is enhanced? How is that innovation primarily driven?
The voice of the customer, we're very focused on that. And as an OEM supplier with all the major truck companies and off-highway companies that manufacture equipment, we get a lot of requirements from them and then develop the ideas in our own test facility right here. But a lot of the information and the requirements, they come from the voice of the customer.
We're going to take a quick break. We'll be right back. Are you tired of overpaying to accept credit cards for your business? National Credit Card Processing Group is the premier payment processor for the heavy-duty truck parts and repair industry. They will lower your fees in 2 steps. First, they're going to review your statement. Second, they're going to show you how to drop your fees. It's that easy. Find out exactly how much you can save. Head to nccpgroup.com today. We're back from our break, and before the break, we were talking all about the features of this RCX fan drive manufactured by Horton. Dale, we're recording this right now. It's the fall of 2021 and winter's coming. What technology does the RCX fan drive have that helps with cold starts for people who live in northern Canada like me?
Well, the basic function with the viscous fan drive, especially with the Horton RCX fan drive, is there's the internal rotor, which is like an impeller inside of a pump. We'll put it that way. And it's rotating whenever the engine is rotating. And there's fluid inside of this fan drive, a silicone viscous fluid. When the valve is open, there's a reservoir that holds this fluid internally. When the valve opens, that fluid exits the reservoir and into the working area of the fan drive. Then when you put power to it, it closes that valve. And when it closes that valve, it doesn't allow any more fluid to go into the internal workings or the working area of the fan drive. And as it's rotating, it pumps the fluid out, and then your fan speed drops. And the design of the valve inside the RCX is such that when it's been sitting for at least an hour and a half to 2 hours, that valve is open. And in older models of viscous clutches, that fluid has a gravity flow and it flows in and it fills up that working area. With the Horton design, that fluid isn't allowed to flow in there until it's rotating when the engine is running. So when you start it back up, it closes that valve and it pumps the minimal amount of fluid in there, and your fan speed drops faster because there isn't the volume of fluid in there like there were with the older models of viscous clutches.
Well, for all of us in those colder regions, we appreciate that because unfortunately, there's a few months ahead of us here where we're going to be facing cold starts. So let's just go from the top. When we look at all of these features and benefits, at the end of the day, like you said, Horton's responding to what customers are asking for based on the environments that they're working in. And so what really is the impact on cost of operation or cost per mile when you opt for the RCX fan drive?
It varies by application. I don't like to put a lot of numbers on it, but we've had some customers that, because of the operation and the smart clutch technology, to speak, that they've seen an improvement because of the, reducing the full-on fan time. For example, in a residual garbage truck, for example, or a, residential type garbage truck, did some testing. The fan clutch in an old pneumatic turned on 57 times in 2 hours. We put on an RCX fan drive and it reduced it down to less than 9 times. And that was 9 full engagements. Because it's not running at full speed all the time, it can be more efficient at cooling the engine, and it doesn't require to turn on the full speed.
Right. And of course, this is dependent on the vocation, depending on the work environment. But this is not a minor little marginal improvement. This is a significant improvement.
Yeah, and over the road vehicles have seen anywhere from 0.3 to 0.5 of mile per gallon improvement over the different models of fan clutches. Again, the vocation and the application is specific to those and how
Right.
the vehicles are operated.
For over-the-road trucks that are traveling large distances every day, that little bit of fuel, it doesn't sound like a lot, but as we all know, if you're paying for the fuel, it adds up quick.
$4 a gallon and you have 250 trucks and you get 0.3 of a mile per gallon and you're running from Georgia to California. That's quite significant.
Yeah, that's going to pay for itself pretty quick. So you've worked at Horton for 33 years. What's one thing you've just loved about the company and working there?
I'm a farm boy from North Dakota. and our factory is out in South Dakota, just 30 miles from where I grew up when I started there as a machinist. But Horton is a family-owned company, and we're all treated like family. And they've afforded me the opportunities to advance. One thing, they're community-minded and focused on the customer. It's about doing the right thing at the right time and being fair and honest. Anyhow, so that's what I enjoy about it. And it sounds cliche, but you're part of a family.
And that's not insignificant. One of the things that we say at the Heavy Duty Parts Report is the trucking industry is the backbone of society. And it is so important for us all to do whatever we can to support that industry. And so it sounds to me like not only did you find a place where you could call home, but like you said, it aligned with your values, and it feels really good to be able to play a small part in contributing to helping the trucking industry move forward because it's such an essential part of our society. We need it.
Yeah, it's truly a relationship business. That's what I've learned in my 33 years, that you build the trust and confidence of your customers, and your products will carry you through.
Yeah, it's amazing, right? Listen to the customer, give them what they ask for, and sometimes give them a little more, and they will always take care of you.
Yeah.
You've been listening to the Heavy Duty Parts Report. I'm your host, Jamie Irvin. We've been speaking with Dale Johnson, a field service manager at Horton. To learn more about Horton, visit hortonww.com. Links are in the show notes. Dale, thank you so much for being on the Heavy Duty Parts Report. I really appreciate it.
Thank you, Jamie. Thanks for having me.
Would you like to buy any of the parts discussed on the Heavy Duty Parts Report? Head over to heavydutypartsreport.com/buy parts today. Thank you for watching this video. Click here to subscribe to the Heavy Duty Parts Report YouTube channel and click here to watch another great episode.